For our acid-base reactions, we need to remember that hydrogen, the moles of hydrogen, needs to be equal to the moles of hydroxide. That is the point where we are for neutralization. So in order to neutralize something and get a pH of 7, get rid of all the hydrogen and hydroxide, those moles need to be equal. That will lend itself to an equation, molarity of acid and the volume. Molarity times volume does give you moles. So we do have this equation MAVA MBVB, which really just has the moles of hydrogen are equal to the moles of hydroxide. Or you can just do it with a little bit of logic, and if you know how many moles of one you have, cancel out the other. So if we need to neutralize 40 milliliters of acid, so 0.04, I'm just going to do it with a little bit of logic here, 0.04 liters, and we know our acid is 0.6 molar. Okay, that means we have 0.024 moles of acid. And I'm just going to worry about the hydrogen here. Well, that means I need 0.024 moles of hydroxide to neutralize it. So if we look at our base, 0.024 moles of hydroxide, we know the molarity is 0.8 moles of the hydroxide per liter, and that will give me 30 milliliters, 0.03 liters. Okay, let's move that over here. So 30 milliliters. And we need 3 sig figs there, 30.0 milliliters. Yes, you can put those equations into MAVA and MBVB, but that equation sometimes has its limits, so it's also good to know the concept. If you have the moles of one equal to the moles of the other, then it's kind of a quick conversion to go between them, even if you don't have a balanced equation or anything. Next problem, we need to be careful here. How many milliliters of 2 molar calcium hydroxide is needed to neutralize the HCl? So we'll go through the same process. Let's do this. Let's do this one with the equation. MAVA equals MBVB. My acid, we want our moles of acid, H plus, is going to be, my molarity is 2.0 molar. My volume is 50 milliliters. Now we're allowed to keep it in milliliters in this equation as long as my answer on the other side comes out in milliliters, which is totally fine. The molarities will cancel out. This one, though, we got to be careful. And bases do this, acids don't. My moles of hydroxide, if you're paying attention, you'll notice that this is calcium hydroxide. And there are 2 hydroxides there. So 2 molar calcium hydroxide is actually going to give me 4 molar hydroxide. Because we want the hydroxides and the hydrogens to be equal, not the calcium hydroxide, the actual hydroxide. This is simple math you can do in your heads once we get that out. 2 molar to 4 molar is going to give us half, 25 milliliters, 2 sig figs of the base. Now the last examples were simply analyzing 2 knowns, a known acid and a known base, how the moles of one can be used to neutralize the other. But we use this a lot of times for analysis of unknowns. So the concept is still the same. We need to remember that the moles of acid are equal to the moles of base. Okay? Because when we have unknowns, usually one of these is a known, and then we can convert back and forth between them to figure out the other unknown. And we do that with titrations. So we wish to determine the molarity of a solution of sodium hydroxide. So we have an unknown sodium hydroxide molarity. To do this, we titrate 25 milliliters of the sodium hydroxide, which has phenolphthalein in it, which is an indicator, background information there, with a known hydrochloric acid. So we have a known hydrochloric acid and an unknown NaOH, but we have the volume. The sample turns clear after the addition of 42.95 milliliters of acid. So the concept is the same here, it's just giving you a context. My moles of acid is going to be the molarity, so 0.1067 molar, and it's going to take me 42.95 milliliters. The base has an unknown molarity, so the molarity of the base, but the volume is known, it's 25 milliliters. Now we can just compare those and get an estimate. If I've got 42 milliliters and 25 milliliters, it's taking me about twice as much of the acid. That means the acid is probably twice as concentrated, or a little less than twice as concentrated. And we can see that is the case. You solve for the molarity of the base, and we get the milliliters are going to cancel out on both sides. So milliliters are fine as long as they're both in milliliters in this particular equation. If you were calculating over to moles itself, you need liters. But we get 0.1832 molar of the base, sodium hydroxide. Now this problem, you can't just use the molarity of the acid, volume of the acid equals molarity of the base, volume of the base. This is a little bit more conceptual. Now we have an unknown and we need a molar mass. The difference about that, you don't need to memorize equations, but you do need to know how to use units. Molar mass is in grams per mole. And if we're talking about acid, it's grams of the acid over moles of the acid. So when we read this problem, we see we're looking for those two variables. We need the molar mass of an acid. The acid contains 1 hydrogen per molecule, which is important, but for right now, that's not really something that we need to worry about. It just needs to be there. You weigh out 2.879 grams of the acid. So it's a solid acid, and that's one of our variables. So really, if we have the moles of the acid, we can solve this problem. How do we get the moles of the acid? Well, it's titrated with 0.1704 moles of sodium hydroxide, and the end point is after 42.55 milliliters of sodium hydroxide. So we have our base information over here, and titrations, remember, they tell us that our moles of the base are going to be equal to the moles of the acid. So I don't want my molarity and volumes here, I just want the moles. So this is just a simple conversion, and then we're going to use the moles of the acid. Since I don't have molarity and volume of the acid, that other equation isn't useful. So it's better to think about this than to just memorize your way through it. The moles are equal. If you have the volumes and molarities, you can calculate them. So our base is going to be 0.04255 liters. Now that has to be in liters because we're trying to get to the moles, and every 1 liter is 0.1704 moles. And that's going to be my base molarity, or moles rather, 0.00725 moles of the base, which comes over here, and that is also the moles of my acid. So that's the real power of that. And then when I take my grams divided by moles, that's a molar mass, grams over moles, we get 397.1 grams per mole.